There are degrees of freedom. It's kind of maybe a little frustrating because when I was a student, I remember the books that I had, excuse me, they would all say one of two things. They would either say degrees of freedom are beyond the scope of this book, or they would just say, "Oh, you don't need to understand degrees of freedom. We don't use them." Well, that's not quite true. Degrees of freedom, although there are ways of figuring out degrees of freedom without really knowing what they are. But the thing is that in APA, the American Psychological Association, if you go to publish, let's say, a paper where you've collected data and you want to share the results of that study, then APA is going to mandate that you report degrees of freedom. Okay? Again, once you know what degrees of freedom are, you'll see that there's other ways of easily figuring out what somebody's degrees of freedom was or were. But anyways, so I'm going to take a few minutes and explain degrees of freedom, and you'll see that it's really not all that complicated. And you'll just have to live with, well, if I ever have to, ever want to publish something, I got to report these. Okay? All right, so again, the reason why we're using degrees of freedom in this discussion is because you need them in order to get probabilities when you're using a t-table. All right, so what are degrees of freedom? Z and t-tables, well, first of all, they both find areas under the curve. Sorry, we're not talking about degrees of freedom yet. That was a misspeak. I misspoke. There's a few more things here I need to tell you before we actually look at the degrees of freedom. So Z and T tables, they both allow you to find areas under the curve. The difference is with a Z, you just need the Z and the table and you're good to go. But for T, you need not only the T score that you want to look up, but also degrees of freedom. Okay? All right, I repeated myself a lot there, didn't I? All right. Here's a definition for degrees of freedom. Number of scores that are free to vary. Now, that in and of itself tells you just about nothing. So I'm going to play a little game. And normally this is fun in class because, it's going to lose kind of the flavor if I try it. I mean, I'll try it, doing this recorded lecture, but just so you know, it does go better with a live audience. All right. So, saying that the degrees of freedom are the number of scores that are free to vary is basically saying that if you want to calculate something, like, for example, the mean of a sample, all right, when you calculate a statistic, the scores that make up the numbers that make up this statistic could conceivably be anything except for typically one number. Sometimes it's two though, but usually it's just one number. So when we're calculating the mean, for example, all the scores that are making up the mean could be anything. But once you know what the scores are, the last number can no longer be whatever it wants. It's no longer free to vary. All right. So here's an example. Let's say we are told that the mean of our sample, because this is not mu, remember this is the italicized M, so this is an estimate. This is a sample mean. So we're told, but this, by the way, this example would work whether we're talking about a sample mean or a population mean. Okay, so this mean here is 20, and we're told that there are 4 numbers. 3 of those numbers are going to be free to vary. They can be anything they want, all right? They can be anything. But once we know these 3, the last one is determined. So normally at this point, I would turn to everybody sitting in front of me, and I would point to somebody, get a volunteer, and I would say, give me a number. It can be any number, positive, negative, 0, I don't care. Throw out a number. And they would throw out a number. Whoops. We'll get to that in a minute. Okay, so number they threw out, let's just say, is 16. Then I would basically go up to them and say, did I bribe you? Did I speak to you before class and say, hey, I'm going to point to you and you better tell me it's 16, and if you don't tell me it's 16, I'm going to fail you? Did I in any way threaten you or pay you to do this? And of course they would say no. And then I'd go to the next person and I would say, okay, give me a number, any number, positive, negative, big, small, decimal, whatever. And then I would do the same thing with them, and then the third person. And then we would stop. And I'd say, there's only 4 numbers. All right. You know the mean is 20. How do you get a mean of 20 with 4 numbers? The only way this can possibly happen is for the numerator here is 80. So in other words, the 4 numbers, and there's a missing number, these 4 numbers must sum to 80, because only 80 divided by 4 gives you 20. So what is this missing number? Could it be anything? And of course the answer is no. It has to be 81. It's determined. Because once you've got these 3 numbers, which were free to vary, there's only one number which, when you add it to these 3, will give you a sum of 80, and that is 81. All right, so when you add up the 4 numbers, you get 80 divided by 4 is 20. The 81 is determined. So to figure out degrees of freedom when we're calculating the mean, we would say it is n minus 1. N, we have 4 numbers, minus 1 equals 3, right? 4 minus 1 equals 3. 3 numbers are free to vary, 1 is not. All right? Now, again, you might be thinking, oh, like, I don't understand why APA wants us to report degrees of freedom. Because really, degrees of freedom, when we look at something like the mean, it's n minus 1. So if we know our sample size is, let's say, 100, then degrees of freedom is 99, right? Or what about this? What if I said degrees of freedom is 48? Could you tell me your sample size? Yeah, you just have to add 1. If degrees of freedom were 48, that means our sample size is 49. It's always going to be 1 more. The sample size is always going to be 1 more than the degrees of freedom. And if I give you the sample size, then degrees of freedom is 1 less than the sample size. Now that's true when calculating the mean. There are some statistics where the degrees of freedom are n minus 2. And we'll get to that when we talk about something called correlation. All right, but you might be thinking, so again, why do we have to report degrees of freedom, when we publish in an APA journal? And it has to do with verifying that the statistical test was run and interpreted correctly. Because when we run statistical tests, which you haven't learned yet, but when we do get to that part in the class, you'll see degrees of freedom are a little more complicated in their calculation for statistical tests. Just for simple statistics, it's pretty easy, but some of the tests, it's more complicated. And knowing, what they should be, I can look at somebody's statistical test results and I could say, that's impossible. Looking at your degrees of freedom, you did something wrong, or you misinterpreted, you looked at the wrong place of the output or whatever. So I'm guessing that that's why APA has us report degrees of freedom. All right. And with that, we are done with Chapter 5.